All right. Good morning, everybody.
Good morning.
I'd like to welcome you to our second podcast in this series of many. This podcast is going to be brought to you by the Pie Shop, of course, located here in downtown Fresno at 1755 Broadway, which is the space we're in right now. This is our industrial space. You can see behind me that we're moving in some new machinery every day. If you were tuning in a few weeks ago, you saw probably a lot fewer things here. So we're gradually building up the space and bringing in machines, and we have a new laser table in here and some welders and some other things. This is also being brought to you by Blue Dolphin Design Engineering. So today's podcast is going to be on the subject of prototyping, something that Blue Dolphin has a lot of experience in, and Blue Dolphin's been doing it for the last 2 decades. And to address that, my guest is Sean Curran. Welcome, Sean. Good to see you.
Thank you, Mark. Thank you. Good morning.
Sean is a graduate of Fresno State, and he graduated the mechanical engineering program in 2005. He went to work for BK Lighting, which is where I found him when Blue Dolphin Engineering joined forces with BK Lighting to become their engineering arm, and that was in 2008. And shortly thereafter, Sean became the engineering manager for Blue Dolphin Engineering.
Probably about 3 years later, I think.
Yeah, 3 years later, yeah. So, which has been wonderful. It's made my life better. And so we're going to talk about prototyping today. So, good deal. So, okay, so let's talk about, where a prototype comes into a project. I mean, somebody comes with an idea, and they have this wonderful thing. They're going to sell 1 million of these things. It's usually what we hear, and hopefully they do. So how does the prototype come into this? Where in the process, and what is it? What is a prototype?
So once a design is created on the computer, once we have everything laid out to as far as we can get, we've analyzed it, we've tested in the computer, we've done motion studies or fluid dynamic studies, whatever we've had to do to get as far as we can in the computer to where we think it's ready. We think it's ready. This is something we want to make. And what we want to do is take everything that's on that computer and build it in real life. And that's the prototype. And that's what we're looking to do. Because until you actually make a physical representation of something, you don't really know how successful it's really going to be.
Okay, so prototype, but some people call them mock-ups. I mean, what's the difference there?
Right. I like to really differentiate between mock-up and prototype. A mock-up, a lot of people call a mock-up a prototype. They call them the same thing. A mock-up is really this is the thing that you built with cardboard and duct tape and parts that you bought at Home Depot. You have PVC pipe going together. That's your mock-up. A prototype is something that, and your mock-up may be a proof of concept. Very useful sometimes, helps to get the point across, but it's not a design typically. Typically, it's just your thoughts with Home Depot components all put together. What a prototype is we've gone through this whole design and analysis process. We've put engineering behind the design itself, and now we're ready to physically make a designed product, and that's what we call a prototype.
Okay, all right. So I know some people with the process with Blue Dolphin, typically, of course, what happens is we do as much of a complete design in computer before we move into the prototype stage. But there's other ways of approaching the problem of creating a prototype, like design build. And
right.
So can you kind of address the differences between doing the design prototypes versus design build, that kind of thing?
Right. So what we talked about already is the design to make a prototype. We talked about, we designed the computer, we analyze it. We use finite element analysis, or we use computational fluid dynamics. We do everything we can to work out all the details in the design right away, up front, before we build anything. Because when you do a design in the computer, that's where it's easy to make changes. That's where it's easy to, well, relatively easy to make adjustments to your design. If I want to make something a couple inches taller, well, that's me just changing a dimension in the computer. If I have something physically built, that's much harder to do. So we try to do as much design iterations in the computer as possible before we make a physical prototype, because when you start cutting material, the costs tend to go up really quickly. The other approach is design build, which is what you mentioned. And typically the driving force behind design build is, I want to get this done fast. I have a deadline to meet. I want to get this done as quickly as possible. So let's not waste time in the computer. Let's just start cutting material and building things. Very similar to the MockUp concept, right? But trying to merge the two, trying to do a little bit of design and then a little bit of build and a little bit of design, a little bit of build. What tends to happen from our experience is the design build tends to take a lot more time than originally thought, right? Usually the driving force is shorten the time, but a lot of times it just increases the timeline. Because all those iterations that I said are easy to do, like I type in 2 inches taller, I'm done, that takes a lot more time once I'm actually cutting. Now I have to actually make a piece component that makes something taller, so we tend to do this Band-Aid step where we're putting Band-Aids everywhere and trying to make these iterations on what we already have. But what also happens oftentimes is to build anything, you have to buy materials. So you end up looking on the computer, on Amazon, or with MasterCard, and you find all these things that you think you need to make this. And you buy all these parts. And then once you actually start fitting them together, because you didn't do a design, you didn't say, does this fit? Do these two pieces fit together? Now you get two parts, and you try to put them together, and they don't work. So what happens is you say, well, I bought the wrong one. Let me go put it on the shelf. I'm going to go buy another one. Well, that's money you just put in storage. So you got to pay for storage wherever you're putting this thing, and then also you had to buy another one. And then what ends up happening at the end of the project is we end up with a pallet full of extra parts. Sometimes I think we got 3 pallets back there.
Yes, yeah.
Of extra parts, and that's oftentimes what happens as a result, because you can't predict what you're going to do. The analogy that I was thinking of was, if you were looking for a house in a neighborhood, and you're going to a party or something, you're looking for a house, you can either just blindly drive around the neighborhood looking for that house, or you could open a map before you get in the car and find out, where is this house?
Sure.
How do I get there? I make a left turn here, a right turn there. Right. It's the third house from the left.
Right.
That's a much more direct approach, but it takes time up front.
Yes.
So before you drive, you have to look at your map. And your thought is, well, if I just hop in the car now and get to the area, I'll find it faster, while you wasted time at the tail end circling, looking for the location.
Yeah. So I guess to reiterate here, there are different ways of going about getting to that first prototype. By and large, Blue Dolphin, if it has the choice, will always choose to do the design in CAD before it goes on to the prototype stage. And almost always trying to do it the other way, where you just start putting stuff together before you have a design, costs quite a bit more time and money in the long run, and a lot more heartache. So our preferred method, and it's been tried and true for decades now, is to try to design as much on the computer as possible. One of the things about having that computer design is that you can do things with that design from the computer. Mm-hmm. You can send images to people to see if they like what it looks like. You can do, it's in 3 dimensions on the computer, so you can move it around, you can animate it, you can do graphical things with it. Even before you've ever created a physical thing, you can do that kind of work with computer-aided design files. So it's important to remember in that process, there's a lot of benefit to trying to do what we believe is the best method.
And ultimately, Blue Dolphin will adapt our resources to however the customer prefers to move forward. We have customers that are adamant, I need a design build, and we say, okay, let's do it. And we'll do our best, but we'll constantly recommend, based on our experience, let's try to avoid that direction.
Right. Okay. Well, so let's talk about a few of the fabrication methods available for doing prototyping. Name some of the, what are the...
Well, usually when you say prototype nowadays, the number one thing that pops in someone's mind is 3D printing.
Right.
3D printing is seen as the prototyping method. Now, I think if you ask the average person, they know what 3D printing is nowadays, which is great, I think. However, a lot of people, if you ask them, how long ago did 3D printing, how long ago was it invented? How long ago did it become the norm? And most of them would say probably just a few years ago, when in reality, parts have been 3D printed.
It's been around from the 80s. The first patents came out in the 80s.
Exactly. So it's been around for a very long time. Now, vast improvements have been made and costs have gone down tremendously.
Right.
But that's seen as the premier method of prototyping nowadays. However, it's not the only solution. It's not always the best solution.
Right.
Sometimes you can prototype a component and as 3D print it. But let's say this prototype, you have to test it. This prototype is meant to lift something heavy or operate in a specific type of environment. If it was injection molded plastic, for example, it would survive. But if it's a wrapped prototype part with the exact same geometry, it may not survive the environment. And that's not telling you that the design is incorrect. What it's telling you is there's limitations of the 3D printing. Now, they've come a long way. Like that UV oven that we recently purchased that actually changes the properties, improves the properties, makes it closer to the injection molded part. But still, sometimes depending on what the use of the prototype is, you may actually decide to use a different method.
Right. So one thing to keep in mind with 3D printing, most people are familiar nowadays with what that is. I see it on the news. They were talking about 3D printing of guns lately. 3D printing is one use of the 3D printer, the actual printing of the part. And just printing of the part, the variety of materials that are available, you have plastic, you have metals, you have what's like paper mache, you can print concrete, you can actually print skin, you can print food, you can print circuit boards, you can do all sorts of things with 3D printing. So there's a number of different types of 3D printing processes. But there's also, additionally, secondary processes. So maybe you don't 3D print the metal part that you're going to make, but you use a 3D printed part as the pattern to create the mold to cast it apart. And we've done that several times.
Absolutely.
Or you use a 3D printed part to create the blow mold, the plastic part. Or you create a fixture to hold two parts together that otherwise you'd have to make it through machining or something.
I've seen 3D printed stamp parts.
3D printed stamp parts, right, exactly.
Stamp die made with 3D printed
Well, right,
material.
sure. So that's a real good example. So there's other, and that's sort of when you come to a company like Blue Dolphin, you're coming into our realm where there's some experience behind what other processes, secondary processes are available to actually use with 3D printing. So anyways, what other types of, there's molding, you mentioned molding and stuff like that. What other kind of things?
There's molding, there's sheet metal fabrication, there's laser cutting, water jetting, CNC machining. You can CNC machine plastic, and sometimes that gives you those properties that you're looking for. Obviously, there's fiberglass. There's all sorts of different methodologies that you can use.
I remember one project we worked on for, it was called the JAMA. And we were making, which stood for Joint All-Terrain Modular Mobility Asset. It was a diesel-electric hybrid vehicle that was a payload for the V-22 Osprey. And we had to machine some rubber prototype parts for them, or fabricate them. We didn't know how to do it exactly. So we were talking about machining rubber. Well, machining rubber is not easy because it's soft and pliable. And
the tools just dig into it and grab it.
Right. So what we did, though, is we dipped it in liquid nitrogen, which made it as hard as steel. And then we machined it while it was cold, and it worked just perfectly. So there's all sorts of things you can do to make prototypes to create things that you need for production.
So Blue Dolphin, we have resources like 3D printing, CNC machining, that sort of thing. Now, there are 3D printed houses out there that you can just email your file to. They'll give you a quote. They'll print it pretty quickly, and they'll ship it to you. However, that's all they do. They're not doing a design analysis. They're not telling you whether your part is injection moldable, whether your parts are going to fit together, or whether this is the right process. They might be able to help you with the material properties and say, well, this material isn't suited for anything that's going to have any kind of load or anything like that. But that's the limit of what they can typically do. Usually they just want to print. So what you're getting, I have a fly. What you're getting with Blue Dolphin is you're getting the engineers to analyze your design, whether you created it yourself or we created it, for what the best method is for your prototype.
Right.
So we're not just going to say, well, we have 3D printers, so we're just going to 3D print it. We would say, well, how are we going to utilize this prototype? What is it going to have to endure? And that'll determine what process we use.
Well, and it's good to mention, I think, that that the design, in general, the focus of a design is related to a number of factors. One of them is the number of units that are going to be actually produced in production, what you envision that to be. The other is the environment, loading, all sorts of things are involved with that. But keeping in mind that how it's prototyped often is different than how it might be produced for production. Right. And so it can, having those things in mind when you go through the design and decide how to make a prototype, it's important because, the prototype is meant to give you a good evaluation of what you're doing. So let's talk about the iterations of what you're doing when you're prototyping.
So one of the first things I say right away when I talk to someone who wants to prototype is I say more than likely 9 times out of 10 your first prototype is not going to be your final prototype. And that doesn't mean that the design was bad. What that means is there's only so much you can do in the computer before you actually build something. We've had some products that are subjective. For example, a part that goes in your hand, it's a grip, it's meant to be held all day. We design it based on how the customer wanted it to look. They said, perfect, that looks like it'll fit in your hand really well. It's the size I told you to make it. Let's print it. We print it out and hold it in their hand and they say, you know what, it's just not right. But also, anytime you're making something that never existed before, what you have to do is to accept that there may be things that you didn't think about. And you may have been thinking about this part for 20 years, but once you show it to somebody else, they may give you insight that you never thought of in 20 years.
Right.
Once you do a market study or once you start showing, just showing to people, see what their take is, more than likely changes are going to be made. There's sometimes things that you thought had to be in this product, absolutely must be there, and you decide they're actually not that important.
Right.
And then there are things that you never thought were going to be important that absolutely have to be in the design. And that requires you to make another iteration, which takes us back to the computer. We make the changes in the computer, like I said, make that 2-inch change. And then sometimes we'll make a whole brand new prototype, or other times we'll actually modify the prototype to make those changes, depending on how extensive they are, really.
Yeah, it's interesting how the brain works. You have this concept in your head that's you've never seen it anywhere, but you've envisioned this. And then after we do our design in CAD, you get to see it on the screen, and that gives you a step closer, and you have maybe more vision and more insight as to what you're doing. But when you get that actual thing in your hands, your brain works even more on the different possibilities. It's amazing the number of times when we actually get a physical prototype in our hands and all these extra ideas start coming out, or these modifications. And so we have enough experience to know that that's, by and large, that almost always happens. So this is also another reason why design build is not always the best way to go, because to get to that point to where you get things in your hands, it costs a lot of money, and to make those changes without having to do design, it can just escalate. And so being able to go through that process with the computer, make changes in the computer where it's far cheaper to have us make changes on the computer than it normally is to make computer changes to a prototype. So it really makes a difference when you get to have that prototype in your hands and work with it.
One thing I want to point out, though, is that the design iteration process is almost necessary in the prototype phase. However, that process can snowball on you. Mm-hmm. That process, because you end up in the mode of continuous improvement, which is a good thought to have. Right. Mm-hmm. However, you have to understand that you never achieve perfection. You always pursue perfection. That's one of those lean manufacturing concepts.
Yes.
A great example that I like to bring up is Apple's a $1 trillion company now, right? Yes. Mm-hmm. You shouldn't call them Apple computers. They should be Apple cell phone company, because that's what's really getting
devices.
them there,
yeah.
right? So imagine that first iPhone. It was awesome. It blew you away, but it's terrible compared to today's technology. Mm-hmm. I have a iPhone 6, which is now old. Right?
Yeah, it's old technology.
Old technology.
Old school.
So imagine if Apple saw that first iPhone and had the vision, let's pretend, to see 4 generations later. Mm-hmm. Apple could have sat there and said, well, let's not release the first one. Let's work towards that 4th generation. Right. So they could have spent 5 more years before they would have actually released it. Imagine 5 years and how many billions of dollars they would have lost in that 5 years if they would have waited. Right. And they could have, at 5 years later, said, well, you know what? We're looking at more technology that we want to add. So let's wait a little bit longer and keep adding these features, and let's get it perfect before we release it. And sometimes that's a dead end. You end up trying to make it perfect, which you'll never achieve. You want to get it. What you want to do is make it the right product for the consumer at that time. Right. That's your goal. You can never make it perfect. Right. You just want to make it as best you can.
Well, and you bring up another good point, and that is with a design, when if you're trying to bring a product to market, sometimes you can't build in all the features you desire. Mm-hmm. You have this laundry list of things that you want to include and what you want to have as part of what you're doing. And then you get into the design process and you realize this whole new feature is a development project all on its own and could cost a lot of money and a lot of time. Maybe for the first iteration we don't incorporate that. And so that's another part of that design prototyping process, is that sometimes the prototype isn't what you even envision in the beginning, because there are practical limitations behind how far you can get that first time through. You don't have the money to spend on $200,000 in injection mold tooling, even when it's made in China, or to have this super precise circuit made that does a special thing. So that also is part of this prototyping process, is realization of what's practical that maybe steps you into the marketplace and gets you someplace. And that's kind of what you're referring to there.
Yep.
So we kind of touched on this a little bit, but so I know people come and they when they ask the question, when they come to Blue Dolphin, they want to have, and for good reason, they want to have an idea of how much this whole process is going to cost. How much is it going to cost? I just have this great idea. How much is it going to cost to give me the prototype?
Right.
And they just want, that's the answer they want. Now, I don't blame them. I understand where they're coming from. But so tell me, kind of, how's that dynamic work?
So often, you're right. What happens is someone comes in and says, I have a budget, right? I have an idea in my head how much I want to invest in this project. How much is it going to cost to get to the point where I have a prototype so I can go out and show investors and I can either sell my idea or get into production? And that's a difficult question to answer because it's a loaded question. It's painting me in a corner, but really the prototypes vary wildly. Some prototypes we've done cost $100,000. We've done the prototypes that were $500. It varies wildly. It all depends on what are we making, and also usually the person that comes in asking that doesn't have a design yet either. So that we have to go through the whole design process before we even move to prototyping.
Right.
So that's also included. And I can't give you a cost on your prototype until I have that design.
Right.
It's the analogy that I hear all the time is like, well, if I want to go buy a house or build a house, I could go find a contractor, they could give me a price, and they would build me the house for that price. Generally, give or take a few percentage changes. However, the difference is there's a whole industry of people that build houses all day long.
Right.
There's a whole, usually a house that you're building is an existing design,
right,
or a modification of that design. Because if you've ever built a pure custom home, you're paying engineering fees because
right,
they have to design it as well.
Sure.
So it's really an unfair analogy, I think, because if you're creating something brand new that's never existed before, there is no industry.
Right.
It is not existing. There are no experts. Nobody
right,
knows how to build this house that you're making.
Right.
So that's why it's a difficult question to answer, and kind of goes back to the topic that we talked about earlier, which is create a design as thorough as possible up front, go through the iterations that you know of up front, then move to making that prototype. And that prototype may be very different than what you originally envisioned.
So what you're saying is basically, and is that Blue Dolphin works in stages. You know, the first stage being
right,
this design development stage, primarily on the computer, which at the end of that point, there's lots of information that comes out of that. You can get an idea of what your product will cost. You can get an idea of what it would cost to prototype then, which would be the next step then. So you would start with the design development step, and then the next step is then the cost and development of the prototype.
And that's not a Blue Dolphin invention, the process. This is the process that's done in industry.
Right.
Any company, well, Apple was our example. Apple is designing everything in the computer first. They're building everything. They're not just hammering cell phones together, right, in the prototype phase. They are designing everything up front, then they're prototyping, then they're going through iterations, and then they're moving on to production. So it is the established process that we learned just from industry experience,
right,
and we're applying it to individuals that are coming in with inventions.
Right. And one of the things we try to utilize too, we're intent on trying to use what's called the Agile Process, which will be the subject of another podcast at some point in time. But what it allows us to do is to continually create iterations of computer designs to a point to where it can be evaluated on a regular basis, so that when we get to the end design, there have been several interactions with the customer. And then when we move on to the prototype stage, we can do that same process once again. And hopefully it allows us and the customer to reach at a really good finishing point, you know, when we're all done. What tends to happen is, in some industries, you're given a design or a specification to create a design, and you start working on it, and you never talk to the customer until you're done. And then you spring the finished product on the customer. Well, his mind has changed about what he's wanted over that period of time. You've come up with ideas. Somehow it doesn't match up at all with their expectations for whatever reason. So by using the Agile process, you have continual interaction that allows for a better solution. And so we try to use that at Blue Dolphin. It's fairly important.
Yeah, communication is key in product development. The worst thing you do is, what you're describing is we call working in a vacuum.
Yes.
That's the worst thing you can do. Anytime, if anybody's ever done group work or worked together with somebody else, you know exactly what I'm talking about. When somebody went off on their own, try to do everything all by themselves, and they get it all wrong, not because they didn't work hard at it, but just because they didn't have the input of the entire team. And that's crucial to make a successful design.
Sure, right. So it's an interesting process. It's really very necessary. I can think throughout my entire career and the entire life of Blue Dolphin, I think of only one design, which was actually a fairly complicated motor gearbox design that went straight from the computer to making a prototype, and that prototype was good enough to actually sell as production, and the production units were actually based on that prototype without any changes. Now, out of the hundreds and thousands of jobs that we have done, and hundreds of customers we've worked with, that's the one instance where that actually happened.
Yeah.
So even on the simplest thing, it's normally the case that you do another little iteration because things just change. It is the normal process, and even in large things, that when we started the space program, that was some very expensive iterations that went through. They went through huge design efforts and huge prototypes, and so.
Well, I like the analogy of NASA, for example, going to space, because I always point out what happens when you rush as an engineer. You don't include enough people. You're just trying to get something built as opposed to get it designed right and work out the details. You kill astronauts on the launch pad.
Yeah,
that's exactly what happens.
Right, and that is the most extreme case of not having enough resources to. And also, it's an extreme case to show you that you can never predict all of the issues that are related to creating a prototype or a design. It is part of that process. You cannot go from starting a design and make the perfect design. It is impossible, although if you let an engineer work long enough, we'll just keep going if you want. So yeah, it's a very good point. Anything else you want to add about this whole prototype subject?
One topic that I think is sometimes lost is, what is the purpose of a prototype? Why do we make prototypes? What do we do with them? Is it just for display purposes? But it can be for testing. We've done prototypes that were immersion testings or were heat testing. Sometimes they are just for display purposes.
Right.
Sometimes they are almost production ready. Sometimes the prototype is the product. Like when we built the cooling system in the country of Qatar, that was the prototype was the final product.
Yeah.
So there's a lot of uses for prototypes, and it's not always what everybody thinks. That's one thing I'd like to point out.
Yeah, that's a good point. Yeah, they end up becoming things for marketing tools, customer development, evaluation, test, just things to mock-ups, but very sophisticated. A production-looking mock-up that maybe does not have the internals, but gives the outside appearance that people are looking for. Yeah, there's a number of things that the
prototype can be used for.
Absolutely, yeah. Well, anyways, I'm hoping that that's given you guys some insights as to what a prototype can be used for and some of its wonderful purposes. Also, some insight to the process, especially the process that Blue Dolphin likes to incorporate, which is doing design, CAD design and development, and then going into prototyping. And hopefully you guys this will stick with you when you come to developing your product and give you some good useful information. So thanks for joining us for our second podcast. Thanks, Sean. I appreciate it.
Thank you, Mark.
Your wealth of information and
happy to be here.
Yeah, good deal. So that'll be it for today, and we'll see you soon. Thank you.
Thank you. Bye.